Hi, welcome to my math YouTube channel, and if you're new to the channel, please subscribe so that you can be kept abreast with new content and new information that I upload on a daily basis. Returning viewer, thank you very much for coming back, and I want to encourage you to keep on supporting the channel to help it to grow. Please share with everyone that you know who is having some issues with mathematics, high school students, university, college, everybody who you think this will help, because we need all the math help we can get, right? Due to what is happening worldwide, persons are unable to go to school, and with a subject like mathematics, less face-to-face interaction means less chances of students being able to fully grasp certain math concepts. So on this channel, we strictly explore mathematical topics from every level. So thanks for being here again. And in previous videos, we have been through these two objectives already. So we have covered this, and I'll leave links in the description for you to find the videos that relates to these two objectives. So we have found the inverse of a linear function, inverse of rational function as well. So we'll now move into how to evaluate expressions involving composite functions, and also how to calculate numerical values involving composite functions. Alright, so let's move straight into this exciting topic. So let's first define what is a composite function. And this says a composite function is created when one function is substituted into another function. Alright, so created when one function is substituted. Look at this word, substituted. Right? So the two functions have to merge in some way or form. So each function by themselves right here is not a composite function, because this involves only the fx function, and separately we have the gx function. So by themselves they are not rational functions, so we have to merge them in some way. And I'll go through examples that gives you a better understanding. So if you notice right here, this was gx, and they actually had to put gx into fx to form the composite function. So composite function like composite shape, compound shape, and from language arts, compound words, where you use two or more words to form a single word, it's kind of similar. So two or more functions form composite functions. Alright, so let's look at some examples. So on the topic of evaluating composite functions now, so we have if fx equal x plus 2, gx equal x minus 1, and hx equal minus x plus 2 over 6, find f2, h minus 4, fgx, hfx, hf2, and gh4. Alright, so for number 1, that says f2. What you're going to do, you're going to go back to the f function. You'll not go back to the g function nor to the h function, because the problem states f, which is the f function. So you go back for that function now. So let me you can write it this way. So you can write fx equal x plus 2. That's the f function. And if you notice right here in the f function, you have a f, you have a x right here, sorry, and then you have a x over this side. So what this is basically saying, if you have f2, that means wherever you see a x, you're going to put 2, right? X here and x here. Well, guess what? 2 there right here, so you're going to put a 2 over this side. And you can, when you're doing a substitution, please put the numbers in brackets. So we substituted a 2. The bracket kind of give you a clearer understanding. So 2 is in place for x, plus that 2, which is equal to 4. Therefore, f2 is 4. So this is for number 1. f2 is equal to 4. And let's move on to number 2 that asks for h minus 4. Remember what I did for the first one. In this case, we are looking at the h function. So do not go to the f function nor the g function. Go straight to the h function right here. So, right? Then you write down your h function. h x is equal to negative x plus 2 divided by 6. Now that is the h function. But they want to find h minus 4. So h minus 4 will be equal to, remember now, you're only doing the substitution for the x. So the equal sign will remain the same. Sorry, the negative sign will remain the same. Put back your negative. And remember I said to put the substitution in bracket. So this will be minus 4. So we put in the minus 4 right here. Right? Straightforward. And everything else remains the same. We'll only do the substitution for the x. Right? So we still have plus 2 over 6. Moving along now. And if you pay attention to this, you'll realize that there are two negative signs side by side. And in this case, it's going to change to a positive. So this will become a positive 4. Positive 4 plus 2 over 6. Which will be equal to 4 plus 2, 6 over 6. Therefore, h minus 4 is equal to 1. Because 6 divided by 6 is 1. Right? I hope you're getting the hang of this and realize that it's not anything too difficult, and you can actually learn this thing if you put your mind to it. Alright, let us put in another page somewhere so we can finish this up. That's it. Alright, so we're looking at number 3. Right? Number 3 looks kind of fancy. Number 3 is about f gx for number 3. Let's go right here now. So 3 f gx, and we can write it like this, f gx. So if you notice the functions that we have, f gx, so you're gonna go back to the original question and look at the f function and the g function. So the f function says fx equal x plus 2. So we have fx equal x plus 2, right? And gx equal x minus 1 equal x minus 1. And if you notice what is happening right here, gx was put into the fx function. So you can consider this like a function, like a machine, right? This is the fx, and gx is like a raw material, whatever that is, like something like sweetie, right? And you put it through this machine that will put on the plastic. So this is the plastic of the sweet, and then the sweetie comes out in plastic, right? So the fx right here, which would be fx, is like a function machine, and gx is like the sweetie that you put into the function machine, and then you get out the sweetie in wrapped paper. So you actually put, so you consider it in a case where you put gx into fx. That is why we have gx into fx up here. So you can consider it in a case like that. So in that space now we can continue. So we have investigated that you have to put gx into fx. So this function will have to go into this function. So, and it has to go wherever the x is. So this will be equal to the x starts it, the x start the f function. So the substitution has to go right here for the x. Right? So what was gx? Gx was x minus 1. Remember, it only goes where the x is, so the plus 2 remains the same. Plus 2 equal x minus 1 plus 2. Right? So this is equal to x plus 1, which would be fgx, right, is equal to x plus 1. So please stick to the explanation that I'm giving you. It can be a little bit tedious sometimes to see the more abstract concept, but please watch the videos as close as possible and you'll be fine. Right, so I'm gonna finish this up in a next video. So please see the other part, which I'll leave the link in the description so you can follow each step and have everything connected in one piece. So join me in the next video.